In this video, we will learn about manufacture of ammonia by Haber's process. Raw materials or reactants required are the first one we have hydrogen. It is normally obtained from water gas which is Bosch process. Water gas is an equimolar mixture of hydrogen and carbon monoxide which is CO. But these days, hydrogen is obtained from natural gas. Then the second reactant we have nitrogen which is obtained by fractional distillation of liquefied air. So let's have a look on the reaction. When a mixture of nitrogen and hydrogen in the ratio of 1:3 is passed over a suitable catalyst and under favorable conditions of temperature and pressure, these gases ultimately combine to form ammonia. Here is the reaction we have. N2 on reacting with 3 molecules of hydrogen will give us 2 NH3 molecules along with the energy which is 96.3 kilojoule. Hence the reaction is exothermic because the energy is being released in this reaction. The equation shows that the reaction is reversible, means ammonia can dissociate itself into nitrogen and hydrogen. Then the formation of ammonia is exothermic because the energy or heat is being released. Then the formation of ammonia is complete by a decrease in volume. Here we are able to see that we have 4 gaseous molecules, but in this case we have only 2 gaseous molecules. Now the favorable conditions required for the formation of ammonia. The first one we have temperature. As the formation of ammonia takes place with the evolution of heat, a low temperature will favor the formation of ammonia. But if the temperature is kept low, the rate of reaction is also slow. Therefore, the temperature has to be between somewhere around 450 to 500 degrees Celsius. Then the second condition we have is that of pressure. The reaction equation shows that 4 volumes of nitrogen and hydrogen to form 2 volumes of ammonia. That's the formation of ammonia is accompanied by a decrease in volume. Therefore, to get high yield of ammonia, the reaction should be carried out at high pressure. Normally, a pressure of about 200 atm is maintained. Then the third we have catalyst. Following catalysts are generally employed. The first one we have finely divided iron mixed with molybdenum which acts as a promoter. Then the promoter increases the efficiency of the catalyst. Then the second we have iron oxide which is Fe2O3 is another catalyst. It is mixed with potassium oxide which is K2O and aluminium oxide Al2O3. These substances act as promoters. Now the process. The plant used to manufacture ammonia by Haber's process as shown in the figure. Purified and dried nitrogen and hydrogen are mixed in the ratio of 1:3 and then compressed under 200 atmosphere pressure. So the pressure has to be very high. This mixture is then passed into electrically heated catalyst chamber containing the catalyst, that is finely divided iron containing a small amount of molybdenum at about 500 degrees Celsius. Then nitrogen and hydrogen combine finally to form ammonia. The mixture of ammonia formed and the unreacted hydrogen and nitrogen exchange the heat evolved in the formation of ammonia with the incoming unreacted hydrogen and nitrogen as shown in the figure. The hot mixture of the outgoing gases contain about 15% ammonia gas. Then the mixture is now led into container fitted with cooling pipes. Ammonia liquefies whereas hydrogen and nitrogen do not. Then the unreacted hydrogen and nitrogen are recirculated by recirculation pump and fed into catalyst chamber. So here is the complete setup for the manufacture of ammonia by Haber's process. The first one we have compressor having high pressure. Here we are able to see nitrogen and hydrogen are being passed through it. Then finally they will pass through purifiers and dryers. Then ultimately we have this catalyst chamber which actually contains iron and small amount of molybdenum. So heat interchanger is also there. Then finally it will pass through this way and finally we will get liquid ammonia. And here we will able to see that the nitrogen and hydrogen which was unchanged or unreacted will pass into that way through this. So this is the complete setup for the exchange, and this again this N2 plus hydrogen will again come back into the path and it will again react with it will come into the catalyst chamber and then cycle goes on. Then this process is repeated over and over again resulting in an eventual yield of about 98% ammonia. The ammonia produced is stored as liquid under pressure in strong steel cylinders. I hope it is clear to you. Thank you.